this problem is different is the domain. If we're just considering the end result, here we would exclude the values of positive 2 and positive 1. But in a problem like this, you also need to consider not just the end result in terms of what's excluded from the domain, but for example, looking at the beginning, the problem started as this expression divided by this expression. In order for this problem even to work or to be defined, we would have had to exclude positive 2, which we already have, but also we have to exclude positive 4. If x equals 4, then 4 minus 4 is 0. We'd be dividing by 0. This would be an undefined problem, and the rest of it wouldn't have mattered. So there is one more exclusion here. X cannot equal 4. So as an interval, we're going from negative infinity to 1, from 1 to 2, from 2 to 4, and from 4 to infinity. So we're including every number between negative infinity and positive infinity except 1, 2, and 4. Okay, 27. We've got this one here, the g function is going inside the f function. So this g function here goes inside the f function for that x. So we're going to get 4 over the square root of x plus 2. Now, two things to consider. X plus 2 is underneath the square root. So let's deal with that first. In order for this square root of x plus 2 to be defined, x plus 2 has to be greater than or equal to 0. Otherwise, you couldn't take the square root of it. But we have to amend this a little bit. Since it's at the bottom of a fraction, we don't want this to equal 0. So I'm going to get rid of that equal to part of it. So it's just going to be x plus 2 is greater than 0, not greater than or equal to. It's pretty easy to solve. Subtract 2 on both sides. X is greater than or equal to negative 2, or from negative 2 to infinity. So this was f of g of x, and this was the domain. There were two things you had to find on part A. Now for part B, now the f function is going inside the g function, so the f function goes inside g right there. So this is going to be the square root of 4 over x plus 2. Now this one's a little bit trickier to find the domain. In order for this expression to be defined, 4 over x plus 2 needs to be greater than or equal to 0. So the way to solve this inequality is, well, let me first show you an incorrect way. It's really tempting to say, well, let's move the 2 over like this, and then multiply both sides by x, and now we've got 4 greater than or equal to negative 2x, and then divide by negative. The reason this way is incorrect is we're not sure the value of x. X could be positive, x could be negative. If we're multiplying both sides by x, we don't know if we're multiplying by a positive value or a negative value. And if indeed x is negative, then we should switch the direction of the inequality. Since we don't know what x is, that method's no good. The way this has to work is to combine this into one expression. So if you think about it as adding two fractions, you have to get a common denominator. So multiply it by x over x. And you're going to get 4 plus 2x over x is greater than or equal to 0. Now this was a topic in 1010, a real difficult one if you ask me, but solving rational inequalities involves a few steps. First of all, you have to find what are called, or what most textbooks call, critical values. Critical values are when the numerator equals 0 and when the denominator equals 0. So we find a real easy one in the denominator. A critical value is when x equals 0. Now here, for the numerator, the critical value is when x equals negative 2. So once you've found and plotted your critical values on a number line, the next step was to choose test values in each of these three intervals. We have this interval from the left of -2, so I'm going to choose a test value of -3. We have this interval between -2 and 0, so I'm going to choose a test value of -1. And we have this interval to the right of 0, so I'm going to choose a test value of +1. The reason they're called test values is you take each of these test values and plug them into this expression to test whether it produces a positive or a negative value. If it produces a positive value, this whole entire region would be considered a positive region, and vice versa. If it produces a negative value, it would be considered a negative region. So testing -3 first, plugged in -3 for both x's. 2 times -3 is -6. -6 plus 4 is -2. And then we would have had a -3. And the most important point here is not so much the value of the number, but whether it's positive or negative. A positive divided by a positive, or rather, a negative divided by a negative is a positive. Now plugging in a -1 for both x's. 2 times -1 is -2. -2 plus 4 is +2. But then in the denominator you'd have -1. A +2 divided by -1 is -2, but more importantly it's negative. And then the test value of +1, 2 times 1 is 2, 2 plus 4 is 6. 6 divided by 1 is 6, but most importantly it's +6. Now initially we were looking for when this expression, 4 plus 2x over x, is greater than or equal to 0. What does it mean to be greater than or equal to 0? Well, those are positive numbers. Positive numbers are greater than or equal to 0. So this expression is positive in this region and in this region. So it's positive from -infinity to -2, and it's positive from 0 to infinity. Now, there is one more catch to this. Since x is at the bottom of a fraction here, and actually here, we don't actually want it to be greater than or equal to 0. We just want this to be greater than 0. So the one fix we have to make is x can't equal 0. So we're going to put a parenthesis around 0, not a bracket. But that's the domain, and that was the composition right there.